Assalamualaikum warahmatullahi wabarakatuh and good morning. Now for exercise number 2 is analysis of a plain truss structure. So this is the truss structure. The total length of the truss is 9 meters and the height of the truss is 3 meters. And we have this truss is supported by pin at this point and roller support at this point and also at this point, which free to move in horizontal direction. And for the all bottom cord members and top cord member here, we use channel sections where the size is 76 by 38. But for other members, the diagonal members, the vertical member, we use equal angle section of 50 by 50 times 3. Okay, and for the load system, we are going to apply two types of loads, which is dead load and also live load. For the dead load, we are going to apply point load at this point and point load at this point and also UDL on this member. So actually for truss structure, you are not allowed to apply load on member. Okay, so since here in this exercise, I'm going to show you that this truss structure can take this load on member, and the staadpro will treat this member as a beam member. So meaning that only for this member you can have shear and bending. But for other members, the staadpro will treat the other members as a truss member, which can take axial load only. So this is the dead load system, and this one is for the live load that we are going to apply to the structure, the horizontal and also the vertical load. Okay, so now after after you study the geometry of the structure, then you can model the structure into a staadpro. Okay, let's start the staadpro. Okay, so for this structure, of course, you need to select a truss structure. It's very clear that the structure is a truss structure. So in this case, it's 2D truss structure. And for the file name, you can type, let's say, example number 2. You can type, let's say, example number 2. Okay, and just accept the default file for your work to be saved into. Okay, and for the title, you can type anything. Probably you can type, let's say, analysis of truss. Okay, and we maintain the unit, which is meter for length and kilonewton for force. Okay, just click next. And since we are going to draw line, just stay on add beam. Actually, this one is if you want to draw line for add plate here. If you want to draw surface, if you want to draw volume, then you need to add solid. And if you want to model the structure using structure visit, you can get from this command, and you can customize later to suit with your structure, and you can add or you can edit the structure using stat editor. This one is about job information. Okay, so just stay on this add beam. Add beam means you are going to draw lines. Go to finish. Okay, now change the view to 2D view. Click this icon to change the view, and Since the length of the truss is 9 meters and the height is 3 meters, so this grid spacing can accommodate the structure. You don't need to change the grid number and also the grid spacing. Okay, because the length of the truss is 3 meter, 3 meter, 3 meter each, and also the height is 3 meters, so you don't need to adjust the grid spacing. Okay, now you can use this button to draw line, snap not beam button. So you can start here, let's say. Okay, and draw this member. It's up to you which member that you want to draw first. There is no such rule. So just draw the line. Okay, when you come to this point, okay, after you draw all this line, maybe you want to draw a line from this point to this point. So here you must be careful, because if you straightforward click this point to draw a line from this point to this point, you will have double member between this point and this point, because you have already one member here, and if you click this point, meaning that you have double member between these 2 points. So in order to avoid this member, so you need to press Control button before you click this point. So press Control button, hold the Control button from your keyboard, and then hold the Control button and then click this point, and then you can release the Control button. Then so meaning that you have one line only between this point and this point, and then you can continue to draw line as usual. Okay, next we still need to draw a line between this and this. I will show how to draw a line between this point perpendicular to this line. So now you need to stop for a while. Just press escape, or you can click this button to stop the operation. Okay, now as I mentioned in exercise number 1, after you draw the geometry of the structure, the grid system is no longer used. You can hide from the screen. Just click this icon to hide the grid system from the screen. Now what I'm going to do is to draw a line between this point perpendicular to this line. So there are 2 techniques, or probably more than 2 techniques to do this operation. The first technique is that you can divide this line into 2. So just click this line. Okay, and you need to break this line into 2. Use this icon, insert knot, and here actually you can insert as many knots as you want, not only 1 or 2 knots. If you want to break this line, let's say into 2 members, you need to insert 1 knot only at midpoint here. In this case, you just select at midpoint, so that this line will be will be broken into 2 parts, okay, into 2 lines. So if you want to break this line with equal lengths into 3 portions, 1, 2, 3, meaning that you need to introduce 2 points here. So if you want to have more than 1 point, just put the number of the point that you want into this slot. Let's say 2 points, then at midpoint. So the staadpro will introduce 1 point here and 1 point here in such a way that the length of this member is equal. So you have equal length. So, but in this exercise, I'm going to divide into 2 equal lengths. So go to at midpoint, then click OK. So here it is. So now if you click this line, you click this line, you have 2 lines. So meaning that in this first step, you need to introduce a point here. Then you can connect to this point using this icon. Add beam. Add beam means add line. Okay, so this is the terminology used in staadpro. Beams mean line. Okay, so just click this point and then this point, or it's up to you whether which point that you want to start. Is up to you whether you want to start with this point, this one is your ending point, or this one your starting point, this one is your ending point. It's up to you. That will change the that will determine the member direction. Okay. Next, I'm going to do the same line here, but on this part, but I'm going to use different technique. Okay, so if you look at this icon, add beam by perpendicular intersection, click this icon, click this point, and then you can click any point along this line. Okay, our aim is to have a perpendicular line between this line and this line. So if you click at any position along this line, the stepper will search a point in such a way that this line will be perpendicular to this line. For example, if you click somewhere here, I see that the stepper still can search the midpoint between these 2 points, which is here, and the stepper will automatically create this line. So the second technique is much easier compared to the first one. It's up to you. Okay, so actually there are many techniques, maybe not only 2 techniques, probably more than 2. Okay, now we have a complete geometry of the structure. Next, we need to prepare section properties. So if you look at this exercise, we are going to use channel section for both top and bottom chord members and equal angle for other members. Okay, so go to general and stay on property, because we are going to set up the property of each member. And the easiest way, just get the property from database. Of course, later in the next example, I will show you how to create our own section or use other section. But for this exercise number 2, I'm going to just take from the library, from the staadpro library or from the database. Go to database, choose a British section, because we are quite familiar with British section compared to other section. It's up to you. Click OK, and then you need to select channel section here, channel section. So search a section of 76 by 38, which is one. The top one is the smallest one. The bottom one is the biggest one. Doesn't matter what section that you select from here, because this one is just for purpose of setting up the individual stiffness metric K, not the final section. So the final section will be determined during the design stage later. Okay, select any section. In this case, I am going to select the smallest section here, 76 by 38. The shape is C, and then the material is steel, and then click add, then close. And here you need to apply to this 4 members here, bottom chord members and also top chord members. So in order to have multi-selection for this bottom chord, you can select this one in one shot. By doing like this, you can select these 3 members in one shot. But if you click this member after you select this member, then straightforward you click this member. Okay, so the previous one will be deselected. So in order to have multi-selection in staadpro, you need to hold Control button. So select this line first, and then hold Control button for multi-selection. Okay, so remember that if you want to have multi-selection, hold the Control button. Okay, then assign with this section. So you have reference 1, meaning that this section, all these sections use this property. Next, we need to prepare a section for other members. So again, go to database, go to British. This time you need to select angle, and let's say you want to use 50 by 50 times 3. Here it is. Okay, 50 by 50 times 3. And the material is steel. Add, close. So now you need to select other members. Okay, then assign, then yes. So this one, the stepper will give this members as R2, reference number for section number 2. R1 is section properties for number 1. This one reference number 1, this one reference number 2. Okay, next we need to prepare support. So I'm going to put pin support at this point and roller at this point and this point, which free to move in horizontal direction. Okay, so now go to support, go to create here, then go to pins, very straightforward. Select this support, select this point, then assign, then click yes. Just repeat the same thing, go to create, but here we don't have a specific command for roller support, and therefore you need to understand the degree of freedom to do customization. So this is the importance of knowledge of degree of freedom in analysis. Okay, if you don't understand about the degree of freedom, you cannot customize the degree of freedom to suit with your support condition. Okay, so if you go to this button, fix button, okay, fix button meaning that this the constraint or release condition of the point. So in general, each point has 6 degrees of freedom in general, okay, regardless the type of the structure. Okay, in general, okay, there are 6 degrees of freedom, which is movement in 3 directions and rotation in 3 directions. So from this, you can see, you can determine which item here should be released. Okay, so this command means fix but, meaning that the degree of freedoms, all 6 degrees of freedom are fixed initially, and then the stepper asks you what are the degree of freedom need to be released to suit with your support condition. So remember that we are going to put a roller support here and also to this point. So since the roller is free to move in horizontal direction, of course you need to release, okay, Fx. You need to release Fx so that this point can move freely in horizontal direction. What about Fy? No, you cannot release Fy. If you release Fy, meaning that this structure will collapse because you have pin support here. So this structure become unstable if you allow this point and this point to move downward. So therefore you cannot release Fy, movement in Y direction, but you can release Fz. Of course we are talking about 2D, this one is not our concern, but you can tick here, okay, if you want. So meaning that the movement in Z direction, is also released or free to move. Mx, you allow this point to rotate about X, that is okay. And also My, rotation about Y, and rotation about Z. Of course this point can rotate about Z direction because roller support can rotate, is allowed to rotate. Okay, so meaning that you need to tick all a degree of freedom here except Fy only. So by doing this, you can have a roller support which free to move in horizontal plane, or in other words in XZ plane, and also the point can rotate in any direction of X, Y, Z axis. Okay, the only item that we restrain is Fy. So that is the behavior of a roller support. So add, and then click this support. So in staadpro, any customized support is shown by this symbol. Okay, shown by this symbol. So it's not important about the symbol. Most importantly about the degree of freedom, which one should be restrained, which one should be released, are the important thing in structure analysis. Okay, so after you highlight this support, I go to assign, select this point. Okay, select this point and also this point. After finish, just click this one. Okay, now we have put a support to the structure. Next, I am going to prepare loads. Go to load here on the left side. So we have two type of loading. The first one is dead load. Okay, the first one is dead load. Or you can type DL or anything. Then click OK. And for the dead load, if you refer to this exercise, I'm going to apply point load first and then UDL. Okay, so go to nodal load because we are going to apply load on nodes. So you can select nodal load. And the value, you can type the value, but you need to put negative sign because the direction of the load is downward, which follows the direction of gravity. Say, let's say then the value is 5. Oh, sorry. Negative 5. Okay. This one is just exercise. We don't care about the value. Just put any value. And then click add and apply to this point. And this point, remember that you need to change your selection mode to not cursor selection mode so that you can select these 2 points, then assign, then click yes. Next, we are going to apply UDL onto this member. Go to member. I'm going to apply to the whole length of the member. So let's say the value is negative 8. And leave it blank for D1, D2, and D3 because this one is a full length load. Okay, and then the direction is global Y, add close and apply to this line. You need to change your selection mode so that you can select this line, assign, then click yes. So now we have finished on that load. But if you want to include self wedge into your analysis, so just click this button, self wedge. Okay, and this one is the direction of the gravity. Just accept this one, factor -1. We can put the load factor later. So here we don't need to put the load factor. Later when we do load combination, you can input the value of the load factor. Then click assign, and then that's it. You see that what is the difference between assigning of self wedge and other loads? The difference is that for other loads, you need to select the member or the nodes where you want to put the load. But only for the self wedge, you don't need to select the member or nodes, because the reason is that when you prepare the section properties, the angle, the channel that you assign to the structure, the staadpro can determine the volume of the steel for each member. Okay, so because the cross section area is there, when you select the section, the size, the cross section area is there, and then multiply with the member length. Okay, you got volume, and then multiply with the the density of the steel, which is already fixed into staadpro, which is 7850 kilogram per cubic meter. You can get weight. Okay, and then multiply with gravity. From the density, multiply with the volume, you got mass time gravity, and then you can get width, which is the safe width of each member. So that's the reason why you don't need to assign the safe width to the structure, only for the safe width. So remember that. Okay. Now we have finished on that load. If you want to create other load, for example live load, go to new load button here, click this, and then for the title you can type, let's say live load, let's say LL stand for live load. This one is not a command, just a command. You can type anything, even in your own language you can type it, and then click OK. So you see that when you create new load, the previous load gone from the screen. It's still in the database, you don't worry. Okay. So whatever load that you apply now become live load. But if you want to recall back the previous load, the dead load, you can get it from here, DL. So it's there. If you want to start to apply live load, just activate this live load and put the load here. If you want to add something into your dead load, just activate the dead load, and then you can apply load here. So that become part of your dead load. So now change to live load. Okay, now go to nodal load, because I want to apply load at nodes. So first I'm going to apply horizontal load in positive axis. So let's say the value is 7, for example. So I'm going to apply to this point, let's say this point, and also this point, and then assign, then click yes. And then I'm going to apply vertical load to these 4 points. Go to nodal, Fy, the value should be negative, let's say negative 9, and then apply to these 4 points, assign, then yes. So these are our live load. Okay, so normally in analysis or design we need to see the load combination rather than individual load case. So in order to combine dead load and live load, you just click this button, combine, and then go to new, and then give name to this load. Let's say LC, stand for load combination. Type, or you can type anything here, click OK. So